define a game when players use mixed strategies, we need to define a strategy profile in mixed strategies. It is a pair of mixed strategy of the first player and mixed strategy of the second player. Then, for the strategy profile in mixed strategies, we need to define a payoff function of the first player. So the payoff function in mixed strategies is a mathematical expectancy of a payoff given that player 1 and 2 use mixed strategies. So when they, for each pure strategy, define the probability that the strategy will be realized. And it can be calculated in the way it is presented on the slide. Let's suppose that the first player, or Colonel Blotto, uses a mixed strategy 0.7000, 0.3, and the second player uses a mixed strategy 0.1, 0.9, 0, and 0. Then the payoff of the first player will be calculated in the way it is presented on the slide and will be equal to 1.81. Another very important thing about mixed strategies is that a saddle point in mixed strategies always exists for any matrix game. The result that is presented on the slide is a fundamental result for zero-sum games. Why? Because it means that we can always find a saddle point for any matrix game. It also means that the conditions for a saddle point always satisfy. So there always is a strategy profile x star, y star for which the two conditions that are presented on the slide are satisfied. And also it means the necessary and sufficient conditions for the strategy profile are satisfied. It means that the lower value of the game is equal to the upper value of the game for a saddle point in mixed strategies. And the corresponding value or corresponding payoff we will denote as V and call the value of the game. For a Colonel Blotto game, a saddle point is calculated in the way it is presented on the slide. For now, we do not say of how we calculated that, but this is the saddle point, and the value of the game or a payoff of the first player in saddle point is equal to 14 divided by 9. On this slide, you can see a theorem which can be used in order to define a saddle point for a simple matrix game. It says that a strategy profile x star, y star in mixed strategies is a saddle point in the matrix game if and only if the following equality holds. The following equality shows that the payoff of the first player, when the first player uses mixed strategy x star and the second player uses a pure strategy which minimizes the payoff of the first player, is equal to the payoff of the first player when the second player uses a strategy y star and the first player tries to maximize its payoff. Using this result, we can solve a simple matrix game in the way it is presented on the slide. For example, we have a matrix game where each player has two pure strategies, and we can say that the strategy of the first player is a vector x equal to xi 1 minus xi, where xi is the probability that the first player will choose a first pure strategy, and the strategy for the second player is vector y, which is equal to eta 1 minus eta, where eta is the probability that the second player will choose a second pure strategy. In order to find a saddle point in the game, we need to solve two equations. The first equation tells us that the payoff of the first player when the first player chooses a first pure strategy x1 and the second player uses a strategy y star from the saddle point is equal to the payoff of the first player when the first player uses a second pure strategy x2 and the second player uses the same strategy y star from a saddle point. From this equation, we can find the strategy y star of the second player from a saddle point. From the equation kxy1 equal to kxy2, so when the first player uses strategy x star from the saddle point and the second player uses the first pure strategy is equal to the payoff when the first player uses strategy x star from the saddle point and the second player uses second pure strategy y2. And from this equation we can find a strategy x star, which is a strategy of the first player from a saddle point. So let's start with the first equation, and the left-hand side and right-hand side of this equation can be defined as a functions of strategies y star of the second player. Then, if we derive this, then we will have an equation eta plus 5 equal to 7 minus 4 eta, and then as a result we can define that y star is equal to eta star 1 minus eta star equal to 2 divided by 5 and 3 divided by 5. So this is the strategy of the second player from a saddle point. In the same way we can define a strategy of the first player x star. For that we will need to consider the second equation, and we need to derive the left-hand side and the right-hand side as a functions of a strategy x star. And as a result we'll have the following equation: 3xi plus 3 is equal to 7 minus 2xi. From that we can derive that x star is equal to xi star 1 minus xi star, and this is equal to 4 divided by 5 and 1 divided by 5. And the corresponding value of the game, or payoff of the first player in saddle point, is equal to 5.4. On this slide you can see a list of references where you could find the proof for the fundamental theorem of the matrix games and zero-sum games, and also you can find a proof for the results that could be used for solving the matrix games.